Hello, my name is Rajasekharan. I'm the Managing Director for the Americas region for the Alliance of Bioversity International and CIAT, a CGIAR center. I want to talk about how we create a globally inclusive approach to foodomics. The science of foodomics is opening doors to revolutionize how we tackle some of the society's most pressing challenges: biodiversity loss, malnutrition, chronic disease, and even food security in a changing climate. But as we stand on the brink of the food revolution, we must ask ourselves, who benefits from this technology? Who has the tools and the knowledge to harness it? And who gets left behind? In this lesson, I will talk you through about why it's essential that foodomics is a shared global resource, one that is inclusive regardless of geography, income, or infrastructure. We will explore why it's essential for foodomics to be an inclusive, globally accessible resource, one that respects the rights, knowledge, and resources of all contributors. Without these commitments, foodomics may end up serving only a fraction of the world, leaving millions without access to transformative power. To understand what is at stake, consider the edible biodiversity that exists in communities around the globe. In a study published in 2023 in Nature Food, my colleagues and I collaborated with 54 scientists to begin capturing and prioritizing this diversity. We compiled a curated list of 1,650 foods from around the world. Astonishingly, over thousands of these foods are not found in national food composition databases. This means we lack basic information on the nutritional or bioactive content, and in some cases, we don't know what this food contains. And these databases overlook a significant portion of humanity's long and co-evolutionary relationship with food. We must center regional edible biodiversity in our foodomics efforts. Even for foods that are commonly consumed and included in nutritional databases, our understanding remains superficial. We estimate that 95% of biomolecules are unknown to science, known as dark matter. We don't know what these biomolecules are, what roles they play in the ecosystem, or how they affect our health. This gap isn't just about scientific curiosity. It's about understanding the complete profile of what nourishes us, what sustains us, and what could potentially be leveraged to improve global health. Ultimately, the biomolecules in food play a critical role in determining food quality, a multi-dimensional attribute shaped by the ecosystems, cultural practices, and economic conditions unique to each place. Food quality varies across food systems, soil health, traditional knowledge, livelihoods, markets, and specific agroclimatic conditions. Capturing these ecological, cultural, and economic factors in the form of metadata alongside food biomolecular composition allow us to account for this complex context, fully acknowledging the diverse influences on food quality that is specific to a place and its populations. Mapping what's in a food is a massive undertaking, too great for any one laboratory, organization, or a country to achieve alone. It requires a unified global movement, one even greater than the Human Genome Project, where governments, institutions, scientists around the world need to come together. In practical terms, building an inclusive field of foodomics means ensuring that the study and applications are not confined to advanced labs in high-income countries. Building an inclusive field of foodomics starts with equity in co-creating technology, collecting data on local edible biodiversity, and applying this knowledge in ways that honor the community's unique culture, resources, and needs. Too often, cutting-edge scientific advancements occur in state-of-the-art labs in high-income countries, while many regions, particularly low- and middle-income countries, are left behind with minimal infrastructure, outdated technology, and limited capacity building. We must be intentional in expanding support for our low- and middle-income countries, ensuring that innovations need to be inclusive, not exclusive. To address this, we need to invest in the capacity of labs and scientists worldwide. We need to be strengthening institutions on every continent, meeting them where they are. By doing this, we can build local leaders who can drive foodomics effort forward in ways that serve their own regions and ultimately the world. The path forward is not easy. There are challenges: financial, logistical, even cultural. Capacity building efforts require time, commitment, and no stated approach to infrastructure and expertise. It's a long journey, but one that is worthwhile undertaking. We must look at the starting point of each participating lab and partners for advancing foodomics. What infrastructure exists? What technology is available? What skills are present? By tailoring our approach based on each lab's need, we create a collaborative and co-creative environment rather than one-size-fits-all approach. This allows foodomics to thrive in ways that respect the unique needs and goals of each partner. The stakes are high, and the consequences of exclusion are real. Let's look at Africa, a continent that has been historically excluded from scientific and technological progress. In the genomic revolution, for example, Africa was largely left out, with less than 2% of human genome studied belonging to African individuals, despite the continent's incredible genetic diversity. As a result, genomic advancements like breakthroughs in disease diagnosis, detection, and treatment are often developed without the specific needs and unique genetic makeup of the African populations in mind. This has left millions at a disadvantage, missing out on potential health benefit. The lesson here is clear: if we don't actively work to make foodomics inclusive, we risk replicating the same exclusion and imbalance in the new field. We risk shielding entire continents, several lives, and countless communities. Thus, we need to build a truly global ecosystem in foodomics. Imagine a world where labs in Asia, Africa, and Latin America and beyond are fully equipped to study and apply foodomics to their local food systems. Imagine scientists from every corner of the world as equal contributors to the understanding of our food, empowered to discover solutions for the unique health and food security challenges of their communities face. By learning from past experiences and committing to building capacity everywhere, we can create a foodomics field that's not only technologically advanced but also just and inclusive. The impact of this goes far beyond science. It's about health, food security, climate resilience, and human rights. In addition to equitable scientific practice, Acts on Benefit Sharing, ABS, introduces a new level of responsibility within foodomics. ABS is an internationally recognized principle affirming countries' rights to control access to genetic resources and to ensure that benefits arising from these resources are fairly shared. Countries are empowered to regulate access to their biological resources, such as indigenous plants or food species, and to mandate fair and equitable sharing of benefits with the providing countries. Traditionally, food composition studies have not been governed by ABS requirements. Historically, scientists publishing data on food composition rarely sought prior informed consent from national authorities or community stewards of these resources. Even when permissions are obtained, they are often poorly documented. As omic techniques continue to advance, blurring the lines between the food composition and digital sequence information (DSI), it's becoming crucial for foodomic researchers to recognize that this work falls under ABS policies and foodomics within the scope of the international and national ABS laws. To understand why ABS matters, we need to be aware of historical injustices where local knowledge and resources were exploited without fair benefit sharing. These practices are often called biopiracy, where plants are commercialized without authorization, compensation, or acknowledgement of local communities. There are multiple prominent examples of biopiracy where traditional resources or knowledge were appropriated without consent, ensuring that local communities are acknowledged and compensated for their contributions to understanding and commercialization of these resources is vital to fostering equity and to preventing exploitative practices. Another essential step in creating an equitable global future is foodomics is to adopt to CARE principle, collective benefit, authority to control, responsibility, and ethics. CARE principles were developed by the International Indigenous Data Sovereignty Interest Group to guide respectful, collaborative engagement with Indigenous communities and to uphold the rights and interests of all research involving their resources. By embedding the CARE principles into Foodomics research, we ensure that communities contributing to this science are not only acknowledged, but also benefited from data sharing. This fosters a science that respects a collective benefit on us local authority, operates with responsibility, and prioritizes ethical integrity. As Foodomics advances, it is imperative that researchers consider equitable benefit sharing with Indigenous people and local communities, who often act as stewards of the planet's edible biodiversity. By upholding these rights, we avoid repeating exploitative practices of the past. By committing to equitable capacity building and ethical practices, we can create a field of Foodomics that's not only scientifically advanced, but also just, inclusive, and respectful of sovereign rights. The impact of this goes far beyond science. It's about health, food security, climate resilience, and human rights. When we build capacity of Foodomics together globally, we are investing in a future where the knowledge and benefits of the science nourishes everyone in societies everywhere.